Interesting. That's a little bit awkward, but maybe I'll get used to that. So welcome to a different format of streaming. So yeah, I recently got really burned out by, you know, the regular streaming. Primarily because I probably was pushing myself too much, I think. Right. So I was streaming pretty much like almost 8 hours a day without any breaks, without any weekends or without any holidays. So that completely destroyed all of my mental defenses, and I became really vulnerable to everything people say on the chat. So yeah, and that completely burned me out. So yeah, if you're streaming, never do that. Never do that. So, but the problem is that I absolutely love streaming. I just can't live without it. It's just like my all-time passion, and it's not only like a passion. What I found is just that it's also a very powerful software development tool, because it acts almost like a rubber duck debugging. I don't know if you ever heard of it, but yeah, but it's actually better. It's actually better. It's kind of difficult to explain why it could be better, but it sort of like forces you to always stay on check, right? It always makes you feel like somebody's watching, right? Unlike the actual rubber ducky. In case of a rubber ducky, you kind of like know that it's like an inanimate object, but in case of streaming, you know that some people are watching you, and it's just like makes you focus on shit like that, and people are sending messages to me. So yeah. So I decided to actually try something different this time. So I'm taking a break from an actual streaming for a while, like for at least a month. I'm gonna try to do something else, something different. I'm gonna try an Andreas Klingstrat. Just a second, I'm just checking the message that I got. Just spam. Don't worry about it. Just spam. So yeah, I wanted to try an Andreas Klingstrat of actually like streaming offline and then like recording it and uploading it to YouTube like afterwards. That way you can still have this like streaming experience, but you're not constantly distracted by a chat, and people can ask questions like after the fact of streaming, you know. So that's basically gonna be the idea. This is gonna be a pilot episode. We'll see how it goes. And by the way, I forgot to mention, if you don't know who the fuck is Andreas Kling, what the fuck are you even doing with your life? So let me find. I wonder if actually this thing Andreas Kling. I wonder if when I'm just recording, it is actually better for my PC. Because I can see that the T is not 100%, it's not percent, it's not 100 Celsius, yeah. So maybe it is a little bit better, I'm not sure. But anyway, so if you never heard about Andreas Kling, check out his YouTube channel. He is the creator of Serenity OS. And he does this like, you know, offline streams. I don't know how he usually calls them, but essentially, as I already said, he just basically records himself working on something and just uploads that to YouTube, right, without the fact of actual streaming. So, and then he interacts with people in the comments afterwards. So I want to try this kind of stuff while I'm on a break from an actual streaming. So maybe it's going to be a little bit better for my mental health. Let's see. Speaking of mental health, if you're lucky enough, you may actually see my PTSD because as I streamed not streamed, but tweeted some time ago. I actually developed PTSD because of the tweet chat. It's so dumb, but I mean, I was never actually diagnosed, but it feels like PTSD. Is that like when I'm coding and I'm trying to, and I'm making a mistake, like I can see the messages with my peripheral vision, because that's where my chat is actually. Right, I can actually see the backseating messages. Like I make a mistake and I can see people, oh, just use this flag or just do that, and it's just like, holy shit. And nobody's there. It's just, it's a PTSD. It's just like anticipation of people streaming their knowledge upon you on how to solve the problem. It's just like, no, please, no. So yeah, maybe we're gonna see something like this in a flying stream. Who needs actual streaming when you have PTSD from the chat and you don't need chat anymore to backseat you? So you backseat yourself automatically. Holy shit, I think I'm going crazy. Anyway, so today is what? Today is Wednesday, and that means today, according to the schedule, we're supposed to be developing a BM, which is a stack-based language with metaprogramming capabilities, and we're going to continue with our usual schedule, right? We're going to continue with our usual schedule. Yeah, so you can probably find the link, I suppose, in the description. I cannot issue a command, but it's located at github.com/tsoding/bm. It's actually pretty easy to type it yourself. And before we start, I need to make a cup of tea, so I really apologize. I didn't make a tea in advance. So yeah, this is just like a regular streaming, so there will be a lot of dead air, and like if you like this kind of content, welcome to our mutual insanity. Anyway, so I'm gonna go just put up some water and I'm gonna Interestingly enough, on the recent BM streams, we started to work on something called a verification. So let me actually go there and fetch the other stuff and see what we've got in here. So this is going to be the status. Yeah, I already worked a little bit on the verifier. I'm not sure what I'm going to do with these changes. Do I want to keep them? Do I want to remove them? Do I have some of them committed or not committed? Because I do remember that I moved verification step to a separate file. So maybe I want to commit at least that to the main repo. So it's 360. Okay, so let's actually try to commit as much as we can before I explain what exactly we're doing. So we have some examples in here. I'm not going to do anything with it. So this is like compute boundaries. So maybe it's not even that important. All of that is not that important. So we were trying to figure out the block boundaries and stuff like that. So let me push everything right into the repo and just make a pull request. And I always make pull requests because I want to check my CI. Because CI builds everything on all of the supported platforms like Windows, Linux, and Mac OS and stuff like that. So I do want to have that. All right. Okay, so what we did in here is extract verifier entity. Is that even a word? Verifier. I don't have a right click because my mouse is dead. It's so bad. Holy shit. Okay, and my tea is ready. Just a second. Just a second. So here's the weird thing. I have two mice. One of them is wireless, but it requires batteries, and I ran out of batteries. Batteries, not batteries. Ran out of batteries, and I just need to buy them. But in the meantime, I have this mouse that doesn't have a right click, but at least it's working to some extent. I have point at things, so every time I need a right click, I have to point, and then with my left hand, then reach to the touchpad on my laptop, because I'm streaming from a laptop, and just like a right click and just look. Okay, so here are the things. My life is a mess. Anyway, extract verify entity, and what else did I want to do? So there was another thing. And check for instruction, for illegal instruction addresses, right? And check for illegal instruction addresses again. I need to reach to my... yeah, that's how you spell addresses. I fucked it up in the commit anyway, but it is what it is, and it isn't what it isn't. So, and check for illegal instruction addresses at compile time. Right, this is not going to close 360, because 360 about verifying the control flow, and that is not fixing the current issue. But it sort of like moves us a little bit closer towards having control flow verification. So I might as well just attach or maybe mention this particular pull request in that issue. So later, if somebody's going to be doing investigation because this you know, thing broke something, they can just go to this pull request and see what's up. That's usually the reason why you want to connect your issues, right? So you always want to connect the issues that are related to each other. I think it's quite important. So here's an interesting thing, right? So you want to usually mention the issues you're working on in your commits. It's going to take some time. It's just like my Git doing its thing. You see, I usually mention those issues. GitHub automatically actually puts them in mentions, which is quite cool. So essentially, why is this important? Why it is important to do stuff like that? So let me show you. So we're going to have something like my paint. And so imagine you have a commit history, right? So these are commits, I would say, right? So these are commits, and here we have a bunch of commits, right? And so on and so forth. So, and then you have issues, right? You have some sort of issues. And I don't know how to present issues, so I think I'm going to represent them as a bunch of blobs, unstructured blobs, right? So commits usually are structured because they have a timeline, right? So there's some sort of a time, and issues are usually unstructured because, well, they also have like some sort of a timeline, but I mean, nobody goes through the issues in order of their time, quite rarely. Right, so it's usually in order of their relevance. And what's the order of their relevance? I don't know, it just depends on the situation, who knows. Anyways, so usually you want to connect, you know, relevant issue, right? So this issue is related to that, this issue is related to that, this one is related to that, and sort of the entire issue tracker is like intertwined and interconnected. So you go to one of the issues and then you see, oh, okay, that issue was caused by that one, but that one was introduced because that discussion, and so on and so forth. And you have this like semantic graph of connections. Furthermore, in the commits, you also refer to different issues. Okay, this commit was about this issue. This commit was about, again, about this issue. This one was about this issue, and so on and so forth. So log history becomes an entry point to this semantic graph of knowledge, semantic graph of discussion. And you know what is cooler is that in Git you have a Git blame feature. Let me show you. This is actually super cool. So again, you browse in the code, and then you see something really weird, like I don't know, like I don't like this part, whatever it is. It doesn't really matter what this code does. And then I say, who did that and why they did that? Like, what the fuck is going on? I'm gonna do blame, right? So I'm gonna do my git blame, and I don't know which one of these options I have to choose. Okay, let's put B, and there we go. And my git, and usually git starts annotating everything, and as you can see, majority of the changes, they have a commit attached to them. So you can now go to a particular commit, and that commit has an issue associated to it, and there you go, you entered this semantic graph from just a line of code. So you browse in the code and you want to think, and you want to know, like, why this thing is there. And if you maintain your commits and issues properly and interconnected everything, you can just enter this graph of knowledge and just explore it and learn why the fuck it was there. You see what I'm talking about? So it's actually kind of cool. There is a reason why I keep doing this kind of stuff, even though it's not particularly useful, because it becomes useful when there's several people working on the project, and there's not that many people who work on my projects because I keep scaring away people with my behavior. But when I was working in commercial projects, these kind of approaches were extremely useful. So I cannot overstate how all of that is super useful. Hope that makes sense. Unfortunately, I don't have a chat feedback to tell me that I'm saying bullshit, so I usually use like a chat as a way of as a reality check. Am I saying bullshit? Am I just, you know, smoking something, or am I saying something useful? But maybe in this time, like a comment section on YouTube is going to be that reality check thingy. Though, if like I have for some reason Twitch chat opened here, so I don't know why. Maybe just in case, if I accidentally press record, right? If I accidentally press record, people will start saying something in the chat, and I will instantly know that I pressed the wrong button. So yeah, that's probably one of the reasons why I actually opened it up in there. Yes, that's the reason why, even though this pull request doesn't fix anything, I still wanted to mention that the issue it's related to, so it can become the part of this semantic graph of knowledge. I'm pretty sure you can make a startup out of this bullshit. Anyways, so so far there was not that many changes in here, probably because I was just moving code around, and let's just merge that right into the repo. And delete the branch, and delete the branch, the branch. Oh boy, where is my soy? Where is my soy? Okay, can I fetch this kind of stuff now? Alright. So I want to pour a cup of tea, just a second. I think I didn't steep it enough. I think it's a little bit weak. Slightly weak. I forgot my salt. Yes. I forgot my salt. Yes, I am one of those weird people who drinks tea with salt. You know. What you gonna do about it? You can't do anything. You cannot even type in the chat. So I already explained the reason why I'm drinking tea with salt. It's because I was when I was trying to lose the weight, I got rid of any added sugar, including the one I used to put in tea. But after some time, tea without sugar like literally tastes like nothing. So just to make the tea drinking experience a little bit more exciting without adding carbs, I started to add sugar, and it actually, yeah, it improves the tea drinking experience a little bit if you can't add any sugar. Which is, yeah, so basically a little bit of salt, like a couple of pinches of salt, enhances the flavor, first of all. And salt actually has a pretty interesting property that a lot of chefs actually familiar with. I watch a lot of culinary videos on YouTube, actually. It's actually insane. Like, I don't know why, but recently I started to watch a lot of culinary stuff, even though I don't really cook that much, and I usually eat very simple food because I'm trying to actually look after what I'm eating. So I'm trying to eat relatively healthy, but I'm still watching a lot of culinary videos, maybe because as the means of, you know, coping with the fact that I cannot eat any of that. So yeah, maybe that's the reason. So essentially what I learned from watching different chefs and you know, culinary YouTubes is that they all seem to be aware that salt reduces the bitterness, which is kind of interesting. And if you oversteep the tea, right, it becomes bitter, which you can combat by adding a little bit of salt, right? So it becomes not as bitter anymore, and you get a pretty strong tea, which is more or less drinkable. So yeah, if you want to, you know, intoxicate yourself with a lot of caffeine, so I guess that's the way to do that. Not like I recommend that, I do not recommend doing that, but it's just, yeah. And then this is probably another reason why people add sometimes salt to coffee, because coffee might be very bitter from time to time. Actually, quite often it's a very bitter drink. But yeah, so I feel like, so drinking tea with salt is crazy enough that I always have to explain why exactly I'm doing, otherwise people think I'm crazy, which is not particularly false, but anyway. All right. So what are we working on? Can I remove this branch already? I think I cannot, because I need to merge the master after we merge everything, and there we go, I managed to do that. So we were working on a verification for our virtual machine. So hello Bosom. So yeah, our language is pretty much assembly for a virtual machine. And you pretty much can do this kind of thing. You can push two numbers on the stack and you can sum them up. You can essentially sum them up, and then after you're done, you have to halt the machine. Right, so but you won't be able to see any result out of that because you need to print them. So to print them, we have some useful functions in the standard library. Specifically, we have dump u64, which basically interprets the frame on the top of the stack as u64 number, unsigned integer, 64 bits, and prints it to the standard output. We also have things like i64, which interprets it as a signed integer, and f64, which interprets it as IEEE 754 floating point number, 64 bits. So yeah. By the way, why are we keep saying IEEE 754? It's like, it's such a common, it's so widespread format that maybe there should be a short name for it. Maybe a short name for such format is a float, maybe, but I don't know. Sometimes, quite often, I want to explicitly say that, yeah, we're talking about IEEE 754 and not anything else, and I don't really know why I have the urge to say it so, because, like, IEEE 754 is, like, literally everywhere. Like, is there any hardware that doesn't use it? I don't know. Maybe there is. Like, I know nothing about. Maybe somewhere in embedded. But I don't know. I'm a programmer. I know nothing about hardware, so you tell me. Maybe there is something there. But anyway, so you can push all of that, and let's actually interpret it as U64, right? As U64, and let's try to compile this entire thing. So first of all, I want to recompile my entire toolchain just in case, just to have a fresh version of this entire stuff. All right, and then I can get the tool chain. I can get the tool chain, and this is going to be a bosom. I'm going to add the library folder to the include path, and I'm going to run this thing on bosom. And as you can see, it actually compiled it. It actually compiled it, and it generated the binary file, the BM binary file, which you can run with toolchain BME, which stands for BM emulator, and BM stands for literally nothing. It's just the name of the system. And we can provide this entire thing, and as you can see, it printed 3, which is pretty much what we expected anyway, right? So we pushed 1, 2, we added these things together, and we call dump U64. You know what's interesting is that this is not a built-in feature of an emulator or anything like that, right? It is literally implemented from scratch in the language itself. That's why I'm so proud of it. So there's dump U64, right? Dump U64, and even dump F64. Yes, we're printing floating point numbers ourselves. We do not support none in inv, but I mean, that's besides the point. So it's not really that complicated algorithm. We actually, what we did is like we found like a paper on what's like the simplest floating point printing algorithm, and we just implemented that. And it's probably super slow, but the question is, do you really need super fast way of printing floating point numbers? Like, who needs a super fast way of printing floating point numbers? Like, what narrow case scenario you need it for? You know what I'm talking about? It feels like it's more like maybe some sort of like physicists need that when they actually print in those numbers to standard output. But why, like maybe it's during some sort of experiment, right? They're taking some sort of experiment and they need to print it to text files, but why would you print it to, I don't know, like I'm just keep thinking like, why would you need like a super fast way to print floating point numbers? I don't know. You need to print them, like a lot of them, for that to actually matter. And what's the case? What's the case? I don't know, maybe there is a case. You tell me. I know nothing. I'm stupid. Anyway, so here's the thing. But you know what's funny is that you can actually screw it up, right? For example, you didn't push one argument, right? You didn't push one argument. This entire thing will compile. It will compile. But if you try to run it, obviously it will error with the runtime, error stack underflow, right? So essentially you have one element on the stack, but plus I expects 2 elements on the stack. So it reaches for the second element and hits the bottom of the stack and it crashes. Right, so what we do with the verification, we're trying to check for situations like that at compile time. Right, so when we're building, I can do something like verify, and it will tell me that somewhere here happens stack underflow, and then you can try to compile and it will compile. Another reason to have verification is because you can literally push anything onto the stack, right? Right, for example, here I pushed 2 floating point numbers, right? 2 floating point numbers. This compiles, but then I'm using operation to sum up signed integers. Also, this works for unsigned integers because 2's complement, but besides the point. Right, it compiles, but it's not really going to work correctly because what our machine does is that when you issue plus I operation, it reinterprets the bits of IEEE 754 implementation and just sums them up as unsigned integer. Right? That's what it does, and it's quite easy to make a mistake when you're doing something like that. So first thing you probably want to do, you want to do something like first of all, like you want to just push unsigned literal in the first place, but if you cannot do that, we have a special instruction that converts float to unsigned, right? And here floats to unsigned, and that will work, right? We want to catch these kind of situations at compile time, and one of the things that instruction have, they have some sort of like implicit information about what are their input types, right? What kind of types of values they expect on the stack, and what kind of types of values they output to the stack, right? And what we did, we went through all of the instructions in here, right? So we have a huge table of instructions. So library bm.c, and yeah, we have like 64 instructions. I think we have a lot of instructions, and for each of them we specified, okay, so here are the input types for this instruction, and here are the output types, and then we can use this information to sort of verify if all of the types match, right? So for example, if I try to compile this thing with verification, this thing will not compile, right? As you can see, expected unsigned integer, but found float. It would be actually kind of cool. I already mentioned that on one of the streams. It would be kind of cool if it also tell you where exactly the expected thing was pushed, and maybe that's what we can work on right now. That would be actually kind of cool, but yeah, it just, you know, fails. So if you do something like this, it will compile, and furthermore, it actually analyzes the control flow, not really control flow, but the flow of execution. Doing something like this, right? Actually, F to U and F to U will also work. It also compiles. It just compiles very fast. For example, look. It recompiled. That's how fast our compiler is. So isn't that amazing? I think it's goddamn amazing. Can your C++ with shed ton of templates and metaprogramming do that? I didn't think so. Well, C++ can do more than this language, but anyway, so I'm just joking, of course. So yeah, that's basically verification in a nutshell, and we stole this idea of the verification from WebAssembly. WebAssembly verification, and yeah, essentially, yeah, Google is absolutely horrible. Google is absolutely horrible. Verification is a crucial step in WebAssembly execution. Essentially, as far as I know, the runtime that executes WebAssembly is not even allowed to execute it unless the bytecode that it receives passes this sort of verification check. So it's just not allowed to be executed. It's like a crucial part of this thing. So, and yeah, the most difficult part of verification is control flow. And this is what we were trying to work on the previous stream. And yeah, I read this article on the previous stream. And the reason why control flow verification works for WebAssembly is because they have structured blocks. Unlike us, we have unstructured blocks, so we have goto and stuff like that. And just like a lot of tricks that they use, like for example, forbidding stack diving. So it's just not gonna work for us. I wish I could share this link, but I can put it in the description, but the problem is that I may forget to put it in the description. So maybe I'm gonna do the following thing. While I'm streaming, I'm gonna maintain the things that I want to mention in the description. So I'm gonna create a file description, right? So txt, right? And I'm gonna put this thing here. So this is the thing I want to put in the description, right? And also one of the things, of course, I want to put this into the description. And as I go and explain things and go through the links, I think I'm gonna just like keep adding these things, and then once I upload this thing to YouTube, I'm gonna put that in the description. I think it's a good idea. What do you guys think? I think it's a good idea. And yeah, so their approach to control flow verification just doesn't work for us. It doesn't work for us, and I was thinking maybe one of the solutions would be to switch to structured blocks. and then use their approach. But I'm afraid that after that, there will be little difference between our virtual machine and WebAssembly. And at that point, I might as well just switch to WebAssembly then. So I might as well just work on a meta programming language for generating WebAssembly, which doesn't sound like a bad idea, to be fair, right? Because it's a very interesting idea. It's like you still have control over WebAssembly, which is present everywhere. It works in the browser, it works natively. In the future, it will probably work on a hardware level, because from the specification of WebAssembly that I saw, it's not that difficult to probably implement like hardware implementation of WebAssembly. Not like I know anything about hardware, okay? So take everything I say with a grain of salt. Haha! Oh, very funny. Tsoding, very funny. Anyway, so but yeah, I think it would be actually kind of cool if BM switched to WebAssembly, but I'm not ready yet. I'm still thinking that maybe we can do things on our own without, you know, how is that, piggybacking off of the WebAssembly. I'm not sure if I'm using this word correctly. I don't really speak English, unfortunately. Not an English native speaker. Anyway, so yeah, that's pretty much the thing we're doing, and yeah, speaking of verification, that's what we're doing in the previous stream. But as I mentioned, while explaining the verification step, I've got an interesting idea, right? It would be kind of cool if this error report would also say where exactly that mismatching argument was pushed, you know? It would say, oh, okay, it was pushed there. So, and I think we can kind of keep track of that. We can keep track of the positions of the arguments that were introduced somewhere and stuff like that. So for example, if you push, we can also remember, so the way verification actually works is that instead of maintaining the stack of values, we maintain the stack of types, right? So when we encounter this instruction, we push type float into the stack and then type float, and then we look at this instruction and we see that it expects unsigned integers, but we have floats in the stack, and this is how we fail. So on top of pushing type, we can also push the location where it was pushed, and also when +i introduces a new value, we can push its location. And for example, instructions like swap, so we can swap things around and whatnot. Swap will preserve the location, right? So when you swap frames on the stack, it also swaps their locations, so you can track it back and print everything appropriately. So that will be interesting, I think. And I don't know if we had an issue for that. I kind of vaguely remember thinking about doing that, but I don't remember if I ever put it to do for that. Oh boy, oh boy, oh boy. Interesting. Anyways, so let's take a look. Let's take a look at where we need to make the changes to actually make that happen. So we have a verifier. Do we have any special to do? The customized stack size, the communication, nothing. Yeah. So this is a very interesting switch case, right? So there is a lot of cases for instructions, but this is because the implementations of all of these instructions is the same, right? You just take their expected types off of the stack and you put their output type to the stack. And if something goes wrong, just print an error. So for majority of the instructions, verification is pretty straightforward. That's why it is what it is. So type check error in the buzz verify program should report the argument number expected but found. Oh yeah, argument number, yeah, and because the instructions can have 2 arguments, right? And it would be nice to have which argument actually failed, but we don't have that implemented. Verification for control flow instruction is not implemented because it's very hard. And we also wanted to have a verification for native calls, and native calls is actually very interesting separate topic. It's a very interesting separate topic. So because our virtual machine is capable of interacting with external C code through native code, and we implemented FFI ourselves completely. It's actually pretty straightforward. It's like on Linux it uses DL open, on Windows I think it uses load library or something like that. It's just like very simple, and load library mechanism was submitted by Cerimon. Thank you so much for submitting it. It's actually super cool. I really appreciate it. But yeah, to demonstrate that it actually works, we have a simple example of SDL, right? So it's a simple SDL application that takes an image and implements sort of like a DVD logo thing that bounce off of the edges, right? That bounce off of the edges, and we can try to run it. So it's going to be a run, maybe something like examples, run, and let's run SDL, and there we go. So this example is pretty much completely implemented in our language, except the visual part. Yeah, except the visual part where it is pretty much SDL. So there's a little bit of tearing on my side, but I'm looking at OBS, there's not that much tearing, which is kind of weird because I think I configured my access to not have to prevent all of the possible tearing. So I'm wondering why would it tear? Maybe it has something to do with OBS, right? OBS uses like a headway accelerated encoding, so maybe it screws up with access a little bit, but I'm just realizing that I don't really care about it too much, right? So, but anyway, so that's what we have, and we can interact with an external code. And it would be nice to have a verification for native calls as well, but yeah, not for now for sure. Anyways, so here is the verification and stuff like that. So the verifier has a stack of types, right? So here is the stack of types. Interestingly enough, we can have a parallel array for locations, right? So it's going to be locations, PM, stack kappa city, right? Stack kappa city. Maybe it would be better to actually have something like frame, stack frame, which is going to be something like type, and this one is going to be file location, right? And this is going to be our stack, right? So we have a bunch of frames. And the size of this array is actually the capacity of the stack, and here we're going to have a stack size, how much we already filled in the stack. So, and when we're pushing to the stack, we can actually call it frame, because we're not just pushing type, we're actually pushing the frame. So in here we can push the type, and we can also push the location. Also push the location, and when we pop the frame, we actually want to receive all of the information, so we're going to actually output the frame. So here's going to be the frame, and Boolean indicates that something went wrong, for example stack overflow or stack underflow, and so on and so forth. All right, so we modified the signatures of these functions and their names, so I'm going to try to recompile this thing and go to the places where all of that fails. All right, let me see. So of course this thing is push frame, but now you have to specify also the file location. Right, it's going to be location, and location isn't used right now, so maybe we have to use it. Okay, so this is the stack size, this is a stack, and what we're pushing in there is the type and the location, right? And only then we are incrementing the size, and if we reached here, that means we successfully pushed something. If we couldn't reach here, we have a stack overflow. Okay, what else? It's stack size. Okay. Note which chat PTSD so far, which is quite surprising. Didn't expect that. That's actually good. I'm super happy. I'm super happy. All right, so this is going to be stack size. Here is a stack size, and then we take stack, and there we go. So this is going to be a frame. Unfortunately, C doesn't have an auto keyword, right? But I mean, I think it has an auto keyword, right? But it actually means something different. Well, I mean, I know precisely what it means. I can even talk about that. Okay, so verify push frame, and when I'm pushing this frame, right, so I have an operand type, right, and I think somewhere in bosom, in a parallel array, program operand, yeah, so we have a program operand types, and we also have a program locations. So that means we should be able to similarly do something like bosom program locations IP. Okay, so that should work. Let's see. Okay, verify pop type. Okay, so when we pop in this entire thing, it has to be just a frame. So in this particular case, we don't really care about what this frame is. That's why we put null in here. All right, so you can actually skip this kind of stuff, which is nice. So this is, oh, and here we're operating on a stack directly. Oh boy, so I don't know, like I kind of want to extract this thing to a separate thingy. So something like stack dupe and stack swap, because it's supposed to preserve the location. To be fair, dupe, what does dupe do? By the way, what does dupe do? Where's my example? Right. So if you have something like this, right, dupe, let's say 1, right, what does it even mean? You cannot see actually, I just realizing that. Let me put myself down a little bit. So if you execute this program, what do you essentially have? You push 1 on the stack and then 2 on the stack. And after you've done that, you can address individual frames of the stack. The top frame, this one, has index 0, not like 0. The frame below it has an indexed 1, and so on and so forth. So basically it's relative to the top of the stack. When you say dupe 1, you're addressing the stack that you want to duplicate. Right, so I say duplicate the one with the index 1. So it duplicates this thing and puts it on top, and of course all of that gets re-indexed. This is the indexing now. This is how it works. And I'm thinking the location, or like source location of the argument, when you dupe it, should it be duplicated, or should it become the location of the dupe? It would be kind of interesting. So yeah, so in that particular case, plus will point out not at this thing, but actually at this thing, which is very interesting actually. So maybe dupe have to duplicate the location instead of setting itself as a location. That's a very interesting idea. I should just try that. And I'm just thinking what's going to be the best way to do that. Anyway, so in here, we assert this thing to be unsigned int, and if it's not unsigned, why did I assert that? Because it's type checked on a different phase of the compilation. Okay, so it should always be unsigned int, because if it's not, that means the previous compilation phase has failed. Okay, so that's totally fine. We take a stack address, and I suppose here we just have to change types into frames, and that's going to be basically it. So this is going to be a frame, this is going to be a frame, this is going to be a stack, stack size, stack address, This one is going to be a frame, so we just, yeah, but by just duplicating it, we also duplicate the location, so there's nothing particularly new in here. So I guess it just works out as it is, which is nice. Okay, let's see where else. It's actually stack size. It's actually stack size, and verify push frame, of course. Push frame, and do we have a frame? Oh, in case of a frame, like, right, we don't accept frames directly, we actually separately accept frame type, frame location, because in some situations it's just easier to pass it like that instead of constructing a new frame. Okay, and swap obviously has to keep track of the locations and whatnot, so yeah. All right. So this one is gonna be stack size. This is a frame. This is a frame. Stack. So this one is going to be. So might as well actually do a little bit of an epic Emacs magic, right? And replace types with stack. Under replaced it actually, so this is also should become a stack. Is that it? Is that actually it? So this one becomes a frame. What else do we have here? Implicit declaration. Okay, so this is a frame, and this is a frame. And do we have anything else to say in here? Okay, actual type. This is not. Oh yeah, so we're getting to actually using the information that we put in the stack. We are getting to the point where we actually try to use the locations in error reporting. Nice. Okay. So actual type, expected type. So all right. So frame. So we can just call it frame, I suppose. Right, so it's gonna be something like this. We're gonna zero initialize it, and this one is gonna be just a frame. Just a frame. So, and this is the stack underflow. So then we have an expected type from the definition of an instruction, and then actual type is the one from the frame, right? So this is a frame time expected type. So I have a feeling that once we have a way to report location of the argument, we don't really need to report the argument number. That's what I feel like. Like this issue kind of becomes obsolete, right? Which is kind of cool, not gonna lie. So yeah. Let's actually try to report all of this. So it's printf, std error, so fl fmt error. Actually gonna be node. The argument was introduced here, and we're gonna just use fl arg frame location, and there we go. And also we should not, what the hell is that? Emacs, what the fuck? Okay, and we also should not forget the new line. All right. And let's try to compile this entire thing, and it doesn't compile. Thank you very much. So because we don't have an actual type, so the actual type now is a frame type. So that's what we have as an actual type. So, and then we're pushing the frame. So what are we doing here exactly? We're checking the output. All right, so we're checking the output, and so what's going to be the location? So definition output types, I guess, is going to be the location of this thing, the program location. I think that's how we're going to introduce all of that, right? So let me see. Okay. Seems to be compiling, and it even passes all of the tests. Nice. Okay, good. All right. So let's test this entire stuff. So now we should report the location of where type mismatching arguments should be were introduced, essentially, right? So I think it's think it's a pretty good thing to do. Let me try to verify this example. Okay, type check error. The plus instruction expected unsigned but found float, and where this float was introduced, it was introduced in here. About that. If we replace this thing with 1, it will complain on a different argument, right? So as you can see, this thing, it was introduced in here. That's pretty cool. That's pretty cool, actually. Yeah. So let me actually try another thing. So if we have something like this, it will obviously compile, but then I can push something like 1 and do plus I. Essentially, after this, we're gonna have one float on the stack and then one unsigned integer, and the float was introduced by this instruction. Will it complain in a correct place? Yeah, it complains at this thing because this thing introduced float, which is not compatible with this plus I thingy. Okay, so now we even have more information in our verification program. This is actually super cool. I really like that. The argument was introduced here. It would be, you know what would be even cooler? To say something like it was introduced here by S instruction. How about that? So we also know the name of the instruction that actually introduced that, because we have a definition of that instruction. I think we literally have a name of this instruction. Let me see. What's the format of the definition? Do we have? Yeah, we do have the name. Look at that. Yeah. So in the definition of instructions, we do have the name, so which we can like pretty much use. So let's recompile everything. And of course it doesn't compile. Of course it didn't compile. I did a forky walkie. Oopsie doopsie. Sorry. All right. And I forgot the place where I did all that. Okay, so it has to be actually after this entire thing. This entire macro system of like custom arguments is pretty cool, but it produces absolutely unreadable compile time messages. It just like makes me so sad. Truly sad. Makes me truly sad. I'm already streaming for an hour. Oh my god. Interesting. And I've done nothing. It's almost like a usual stream. It's almost like I don't need a chat to actually be unproductive. Nice. So yeah. I'm a strong independent streamer who don't need no chat. Okay? So I can distract myself without any chat. But I mean, it's actually, at least so far, 1 hour in, and I'm not frustrated by anything, which actually feels nice. I kind of like that. Kind of like streaming like that. It's really weird. So, all right. So what I wanted to do, I wanted to actually test this entire stuff. Okay. So, yeah, the argument was introduced here by plus I instruction. Wait, what the fuck? I'm using the definition of this instruction instead of the definition of the argument instruction. So that means I need to take the address of, oh, but we don't know the actual instruction address. We don't know the actual instruction address. We only know the file location, and file location is a different thing. File location is a file name plus line, and instruction address is index in an array of instructions. So it's two completely different things. I think we won't be able to easily do that. And to be fair, it's too much effort, so I'm gonna actually retract my statement. So we're not gonna implement that. It's not as cool as I wanted it to be. It's not as cool as I wanted it to be. So I'm gonna just remove this thing. It is what it is, and it isn't what it is. Sometimes software development do be like that. It do be like that sometimes. All right, so yeah, pretty cool. The argument was introduced in here, and we now have that. So we improved the error messages of the verification thing, which is super cool. Might as well actually, since remember I sort of invalidated one of the issues, maybe I'm gonna do all of that in the scope of this issue. So basically all of that is, you know, fixing towards this one. So yeah, I think that's precisely what I can do. Yeah, maybe. 359, 359, and might as well remove this entire thing. And okay, so let's do something like 359, 359 report. Report the location of type mismatching arguments of instructions. Huh. Oh, and a single ass doesn't fit. Single ass. Got you, Hyper. So maybe I'm gonna say something like args. Yeah. All right. Let me push that right into the. I'm gonna push it here. All right. So let me create a pull request. And yeah, this one is going to close 359. There we go. This is going to close 359. Checking formatting, checking Mac OS, checking. Do I even speak English? I don't feel like I'm capable of speaking English, probably not. All right, so as usual, waiting for Microsoft MSVC. I wouldn't even have to fix MSVC. Nice. And also, all right. So I think after this pull request, I'm gonna make a small break because I will need to pee and maybe make another cup of tea and so on and so forth. And yes, all right, the first pull request of today's stream, 1 hour in. My God, I'm being so productive. Holy shit. Oh, this one is interesting. Actually, kind of like this issue. I kind of want to work on that. Okay, I'm gonna put it here as a reminder to, you know, to work on it next. And let me put something like this. It's gonna be origin master. And there we go. We actually improved something. I didn't expect to improve something, but we in fact did. All right. So I'm gonna make a small break because I need to pee. I'm gonna do the usual stuff, I guess, because I'm not editing the SWOTs, okay? So I have enough problems in my life and I don't want to edit anything. So let's put some music on, some jazz that will get me DMCA striked on YouTube and boot it off of the platform, hopefully. So yeah. Not bad, not bad. All right, so small break maybe. Let's put it like this. Maybe I want to adjust my camera. Right, let's make some break. Have fun. You can probably skip that because you're gonna be watching that through YouTube offline. So yeah. Hey yo, what's up? Welcome back to Champions of the Arena, Force and CD. Oh boy, it's kind of like I kind of like this style of streaming so far, but at the same time it's a little bit more difficult because interesting thing about streams is that the chat is also the content, right? The chat is also the content. So if what I have right now is actually like factually less content because there is no chat, right? So, and because of that, like I have to kind of work twice as much to, like, you know, put more content into the video, because like chat sort of sometimes helps to fill in the dead air, and you can always like rely back on interacting with chat. But now I cannot easily do that. So I suppose there's some pros and cons. Maybe this is why Andreas Kling videos are quite short sometimes. They actually, his videos range from like 10-20 minutes of coding to maybe it's like 3 hours, depending on the feature. But if the feature is finished, he usually finishes the video, and that's pretty much it. So maybe this stream is not going to be very long. It's not going to be probably as long as my usual streams, like, you know, 3-4 hours. Maybe it's going to be 2 hours. I kind of want to solve another issue. And also, since I'm a recording, right, so I need to watch out for my for the size of my home. I had 6 gigs at the beginning of this stream. Now I have only 4. So let me see, where is the file. Okay, so I suppose this is the file that I'm currently recording. So it's a May 12th. So if I take a look at the human readable format of this thing, it's already around like 2 gigs, and I'll have to upload 2 gigs of VOD to YouTube. I mean, I have a Russian internet. Novosibirsk internet is actually quite good. At least from what I heard, my internet is better than the German internet, which is already interesting. Anyways, so externality function that converts internal mem address to external mem address. Okay, this one like requires a little bit of an explanation. This one requires a little bit of explanation. So our virtual machine, on top of having a stack, also has an internal static memory, and it even has special instructions that let you access this internal memory. So if we take a look at some of the examples in here, for example, this one, so yeah, there's instructions like read 64U, write 32, and so on and so forth. You push memory addresses on the stack, and then you issue these instructions, and they operate on these memory addresses. But what's interesting is that the memory of the virtual machine is a dedicated memory for that virtual machine, and addressing of that memory starts from 0, right? It starts from 0. You can even just try to access something at the memory 0 and read something or whatnot. So, and that creates a very interesting problem. Especially if you are interacting with C code, right? Especially if you are interacting with the C code. Some C code accepts pointers. right? And those pointers are absolute pointers in the memory, right? They're absolute pointers in the memory. Maybe I should actually draw whatever I'm talking about, right? So let's try to draw that. I think it would be interesting. So we have a virtual machine, right? Virtual machine. And inside of the virtual machine, you have a stack, right? That's what you have. You have a stack of those things. Right, so it's just sort of an array thingy. Then you have a memory, and it's also an array. It's a little bit weird, but it is what it is. It's a little bit weird. So it starts from 0, 2, 3, 4, etc. All right, and this is basically an encapsulated entity, right? It's its own entity. Let me introduce the palette, and we're gonna have another thing in here. So, and then through a magic of FFI, we have some C code, right? So C code. So, and we interact, the virtual machine interacts with C code with something that is called FFI. I'm not really sure if this entire thing is descriptive or not, but I'm trying. So, so sometimes some code may accept pointers. For example, I don't know, something like memcopy, right? Memcopy. This function copies data, n bytes data starting from SRC up to and copies them to the DST, right? So this is how it looks like. So let's actually put it in here. So this is going to be something like memcopy, and it accepts void star destination and the rest of the arguments. So let's imagine that you hooked up this function into the virtual machine, and now you can use it in the virtual machine, except you cannot. Because this function accepts an absolute value, and the addresses that you can operate in this virtual machine are relative to the internal memory of the virtual machine. You see? You cannot take the internal virtual memory address and give it to memcopy and expect memcopy to actually understand what you're trying to tell. Memcopy knows nothing about memory of the virtual machine or anything like that, right? It just expects an absolute address. That's what it does. And that creates a problem when writing bindings for C libraries. Right. So yeah, basically, if you write a binding for a C library, right now you have to do that manually. Right. Right now you have to do that manually. Let me take a look. Right now you have to do that manually, and this is usually how it looks like. You basically adapt a function to the virtual machine, and sometimes it's quite unclear. Does the function that you're wrapping have to accept an internal memory address or an external one? So you see, implicitly we're starting to have the notion of internal addresses and external ones, right? Internal and external ones. And the question is like, which one do I accept? How do I make a decision whether that function is going to accept an internal one or an external one? So the debate that I had in my head was when I was writing some bindings for SDL. So there are such functions as SDL create renderer, right? Create renderer. Which accepts a pointer to the window. And obviously that pointer from the perspective of the virtual machine has to be external bound, because the only way to create a window is through SDL create window call, which always returns you an external memory address, right? So some functions 100% always accept external memory addresses, no matter what, right? So, but some functions may want to accept the internal ones, like for example SDL render copy, right? This thing accepts the render and the texture, which could be also only created through SDL calls, but it also accepts rectangles which you want to construct on a virtual machine side and give a pointer to SDL to the internal memory. So that means you as a human have to make decision. Okay, so these two arguments have to be external memory addresses, and these two arguments have to be internal ones, and you have to put that into the wrapper, right? You have to put that in the wrapper and stuff like that. So which is kind of weird, and like it kind of makes it difficult to implement automatic wrapper generator, and we have an issue for automatic wrapper generation here. So it's like, and I was thinking, how can we do that? And the solution is actually quite simple. Let's introduce a function that converts an internal memory address to an external one, and if when we generate the wrappers, we're also going to generate we're also going to treat all the pointers as external addresses, and it's the responsibility of the programmer for the virtual machine to convert them back and forth. So essentially we can introduce an external native function that just accepts an offset from the internal static memory and just converts it to the absolute value that could be passed to the C code, which is probably a huge threat to the security of this entire system. But to be fair, this virtual machine was never designed to be secure. Right, it can already interact with unsecure C code, so it's more of a, the point of this machine is more of a being portable rather than secure. So the goal of this machine is not to isolate the program, right? It's just make it portable, because we eventually want to be able to generate native code, but right now we're not doing that. We could use LLVM, but I think using LLVM for writing a compiler in 2021 is like using React for writing a website. Essentially pretty basic move. I'm sorry, I didn't want to offend anyone. What I mean is that I find it personally a little bit boring, right? So I'm just trying to do things that are unconventional, right? If everyone is using LLVM, I kind of don't want to use LLVM and want to do something else. I guess, okay, I'm a hipster. What do you want from me? Yes, I said it. Yes, yes, I admitted that. What do you want from me? I'm a hipster. I don't use LLVM because I'm a hipster. Anyway, so our goal is to implement this function. Okay. It's going to be a native function, right? So that means it's going to be implemented in C. But you can call this function through the native instruction, right? You can call this function through the native instruction. So I wanted to demonstrate the like how a native instruction looks like. That's what I wanted to do. Yeah, there we go. This is how we call that. So you have a name and you just say native, and from this point the execution jumps into C code and calls the C code, and once the C code is done it jumps back. So, and the way you can construct native instructions is through a native directive, right? So render copy, right? Where's my render copy? Render copy, there we go. So as you can see, I said there is a native function render, and what it does, it compiles everything and it puts information about native functions to the executable, and when you put it into the interpreter will look up for the names of these functions in the known dynamic libraries, and if it finds them, it will use these functions when you do a native call. So it basically sort of hooks them up, right? And yeah, that's how essentially it works. There's also a bunch of built-in native functions into the interpreters. For example, one of the built-in native function is write, which writes to the standard output. It's almost like a write syscall of Linux. Right, and I feel like the native function external external has to be one of those built-in functions, right? So it's going to be in the standard library, and its sole goal is going to be just converting internal addresses to external ones. And the way you're going to be using that is pretty straightforward. So you push an internal address. For example, you have some sort of a hello string, right? And hello world, right? So yeah, once you define a binding like that, right, it actually puts hello world in a static memory, and it returns the internal address, and it assigns this internal address to this variable, to this compile time variable. What you can do now, you can put this internal address to the stack and then call a native function external, right? And it will take this value and convert it to an external address that you can then pass to other native functions that accept external memory. So that's basically what you can do, right? So because if you do that without this thing, it will use the internal memory address, internal virtual machine address, and this function won't be able to understand what exactly they want from it. All right, so that's the idea of this issue. That's the idea of this issue. Speaking of, yeah, essentially. I remember writing that. It was a long time ago. What I wanted to do, I just wanted to allocate 30 characters, 30 bytes in a static memory for printing purposes. And at the time, the only way to do that was to do it like that. And at the time, as you can see, I realized that it was dumb, and I created to do for that. And I successfully forgot about it. So these days, I think we have a special function called byte array, right? And I think you put the size of the array here, and then a value you want to initialize it with. So the fact that it's initialized with this thing, it's like it's not important. I just had to put something there. But we can initialize it with 0. So this way we are sort of allocating this like 30 bytes of memory. And if you want to still fill it with asterisk, you can do it like that. So it's still gonna work. But we're not gonna work on it right now. So it's like, yeah, it's a very minor, small issue. It doesn't really matter that much. Yeah, let's implement the external function. Should be pretty easy to do. So let me see. Let's start with a simple example. Hello bosom, right? So it's gonna be hello bosom. This is the entry point, and I'm going to allocate hello string. So this is going to be hello world. So this is a hello world, and what we're doing here, we're pushing the hello. And I guess that's it. There's nothing else I wanted to do in here, but I could try to print it. I could include the standard library, so it's going to be stdhasm, right? That's what I did in here. And then I can do call dump u64, because push hello pushes the internal address of this thing. So there is a difference between call and native, right? So native calls to the C code, but call calls to the code within the virtual machine. When you call to dump u64, what essentially you're doing, you're jumping to the function in here. So dump u64, yeah, you basically pushing the return address on the stack, and you jump in here, and then inside of this place where then can return and stuff like that. Okay, so so let's try to compile this program and see what's gonna happen and how it behaves and stuff like that. So I'm gonna do bosom. I didn't really want to verify it, right? So I just want to put stuff like this. Okay, could not read file stdhasm, and this is because I need to include the lib, right? I need to include the lib, and everything went successfully. We have a lot of code in here, but this is because our Our instruction set is very unoptimal. We can make the executables way smaller, but we can work on that a little bit later. Okay, and yeah, here's the problem. Could not find external native function I picked a good name for this function, oh my god. Okay, could not find an external native function external. Make sure you attached all the necessary dynamic libraries via -n flag. And yeah, in BME, you can actually attach DLLs and so on and so forth. But what's interesting is that, as already mentioned, functions like write work without any external like DLLs and stuff like that, and this is because they're hard-coded. Some of the external like native functions are built into the execution environment. They're sort of part of the standard, part of the like POSIX WASI standard, but our own. Yes, soon we're gonna be competing with POSIX and WASI. I don't know. I think I already expressed my take on WASI. So yeah, everybody knows about WASI, which is basically like a system layer on top of WebAssembly. And I'm calling this an attempt of huge corporations to basically compete with POSIX, right? Because POSIX, in a sense, like very similar to what WASI is trying to achieve. And furthermore, mscripton works by implementing POSIX on top of WebAssembly. So right now, WASI does not really compete with POSIX too much because WebAssembly is not really that widespread outside of the browser environment. So not that many people use it like on the backend, for instance, which doesn't really make sense to me. Why would you use that? For cross-platform ability, it's like a Java 2.0, right? So it's like a Java all over again. But I don't know. So what do I know about software development? But maybe there's no problems in here. Maybe WASI and POSIX will interplay with each other, but I mean, I can see WASI being used as a weapon against like POSIX at some point in the future when WebAssembly will become popular outside of the browsers. So this is my hot take. 6 hot takes. Anyway, though I never actually tried WASI. So I programmed a lot in WebAssembly, but I never tried WASI itself. Maybe it's not an issue. Maybe I'm just making it all up. Maybe WASI is basically POSIX. Maybe it's trying to be POSIX compliant. Maybe at some point I need to take a look at WASI. It sounds like a pretty cool idea for a stream, don't you think? Just like sit down and look into WASI. Right. Am I even pronouncing it correctly? Am I supposed to pronounce WASI or something? Yeah. WASI stream soon. WASI. Okay, so what I was doing. Forget what I was doing. Yeah, I needed to implement the external function. Yeah, I needed to implement an external function, and yeah, if I try to do that, some of the functions are hard-coded, and like write and external is going to be one of them. So let's go to the BME executable, right? Let's go to the BME executable, and let me see. So it's going to be. I forgot where it is. It's an SRC. Is it BME? It's actually toolchain BME. So do we have a BM? I think it has to be called BM. All right. Okay. So as you can see, it's literally hard-coded. If the external name write, we're adding native write in here. So that's literally how it is hard-coded. So let's actually take a look at where native write is implemented. Okay, so it is implemented in here, and maybe this is precisely where I'm going to put it. So bm.h native write. So let's introduce something like native external, right? And it accepts the state of the virtual machine. All of these external functions, they are just functions that mutate the state of the virtual machine. They're, from that point of view, they're not really different from the instructions, because instructions are also functions that mutate the state of the virtual machine. So essentially native functions is a way to extend instruction set of the virtual machine. You can look at it this way, which is kind of interesting actually. So it's literally the way to extend the instruction set. Interesting. All right, so if bm stack size, so let's take a look at the stack. So we are accepting one argument on a stack. So that means the stack size has to be at least 1. If it's less than 1, we've got the stack underflow. So stack underflow. There we go. We have to report that. We underflew the stack. Then we take a look at the memory address. So here's the address, and we take a look at the top of the stack. The top of the stack is a stack size -1 because we're numbering elements in C starting from 0 because that's the programmer's way. So here's the memory address, and essentially we also need to check for illegal memory addresses, and this is a pretty good way of checking it. So if this thing is bigger than memory capacity, it's a legal memory address. But we're not looking for the ranges, so this is basically check for ranges. So I might as well just copy paste this entire thing in here. Alright, and after we verify that this is a correct memory address, you know what we can do? We can take our stack frame, right? We can take our stack frame, stack size -1, and basically push a pointer. So we do bm memory, right? So here's the memory. We take a memory at the memory address, and we take a pointer at it, and this pointer is an external pointer. That's how we convert it. It's actually super simple, and it's super simple solution to the problem that I was having. Like basically, how do you decide whether these things are external or internal? Let's just make them all external and make the programmer convert between external and internal. And then we can do something like return error okeg, and everything seems to be okeg. Oh, all right. So, and now I'm gonna go to the BME, right? And it's gonna be something like else if strcmp bm externals native, and if it's equal to 0, we're gonna do push native bm native external. There we go. Okay, and let me recompile this entire stuff. I need to recompile the entire toolchain. So it's gonna be something like no build test. This is gonna be no build test. And of course, so we have other tool that executes our binaries, and this is where we also have to hard code external. This tool is called BMR. It is needed for, you know, recording the outputs of the programs and comparing them against expected output for testing purposes. We actually run it on CI. So let me go to SRC toolchain BMR, and I think what we're doing here, BMR does not provide a native function. So if we have something like so if we convert it into external, we might as well actually just use the regular external one. Why not? I mean, we do have an access to it. So the only goal of BMR is to substitute write instruction so we can capture the output. So for the rest of the built-in natives, we can just use the ones that come with the virtual machine. Yes, let's do that. Let's do that. So it's going to be strcmp bm externals I. So it's going to be name, and so what I'm going to do in here is going to be external, right? This is external equal to 0, and then it's going to be bm push native bm native external. There we go. So let's actually try to compile this entire stuff. Hopefully that will work. We don't have any code that uses this native anyway, so whatever. But all the tests pass, which is nice. So yeah, we do have tests, right? So we do practice TDD, because TDD equal writing tests, right? So let me try to run this entire thing, and external, make sure, am I that much of an idiot? Did I I called it native instead of external. Did I make the same mistake in the BMR2? No, I didn't. Okay. So, but there was nobody to backseat me and tell me that, right? Zozin, you don't understand. You need the chat to tell you that you're making mistakes because you wouldn't be able to figure out that yourself, right? You need somebody who would tell you all of that. Okay, so here's 30. Right, and if I take a look at this entire thing, what we're, this is not that one, it's a bosom. Yeah, as you can see, we're printing just an address, and 30 is an offset from the static memory, and it's really small for a pointer, I would say. So 30 is really small for a pointer. But now let's try to convert it to an external one. So I'm going to call an external. Right, I'm going to try to recompile this entire thing. Right, and then I'm going to try to run this entire thing. And this looks more like an external address now. Yes, this looks more like an external address. External undress. Nice. Okay. So yes, go away fucking this. I guess we just implemented that. All right. So I'm just gonna go ahead and do a committee, and maybe even push it. Committee. So it's issue 351. 351, and let's just do that. Let's just do that. Okay, 351, introduce built-in external native function. It would be nice to document them somewhere. I don't know, where can we document them? So let's actually, so there's assembly bytecode debugger built-in natives. Yeah, let's actually start at least. Built-in natives MD. Okay. List of built-in native functions, and we can make it some sort of like a table, right? So it could be a name and description, right? So we have a name and description, and every time we add one of those built-in natives, we can just append a new line in there. Right, it's gonna be like that. All right. So native, the first one is right. I don't know what to put in the description, and another one is external. So another one is external. Okay. So I think I'm also going to write some sort of signatures for those things. Right, write accepts as a first thing, as far as I know, memory address. Right, this accepts memory address and unsigned int. And I think we can even specify the names of the arguments in here. So it's going to be buffer, and this is going to be the size of the buffer. So basically buffer size. Right, and this entire thing returns actually nothing. I think it returns nothing. How are we going to indicate that we return nothing? Maybe just by not writing anything, right? So maybe it does return something. Doesn't return like a amount of characters that it's written. I don't remember. I implemented it a long time ago. Yeah, it doesn't return anything, so we subtract 2. Okay, very well then. So markdown. Okay, it's kind of strange that I don't have a markdown. I think I disabled it a long time ago. Okay, external one will accept a pointer into memory address, but will return I suppose Cerimon is eating chocolate, so anyway. Okay, so I cannot escape. But it's Cerimon. Cerimon is cool. All right. So write a buffer of a particular size to the standard output. So I'm not going to write like beginner friendly descriptions yet. I'm not going to write beginner friendly description yet. I'm going to just write documentation for people who kind of know what is going on in this project, right? So, right, because like writing beginner friendly documentation is difficult and quite often not needed, right? Because when the beginners come in, they will start asking questions and you can extend documentation based on their questions, right? So for people who know what is going on, the beginner friendliness only distracts them, right? Because they have to skim through it because they already know all that stuff. So we're gonna start by writing documentation for people who kind of know what is going on. We don't have to explain. So that's buffer. So this is the pointer to the memory and it contains bytes and this is a sign. No. So this is for people who understand what is, for example, write syscall, or at least they used a write function from this standard library of C. This is not that one function, but yeah, I'm gonna just do something like this. Yeah, so they at least use something like this, so yeah, they know what is going on here. This one is count. Since when write accepts count? Writes up to count. Oh, I'm sorry, I'm already going crazy. Okay. All right. Convert internal virtual machine address to an external pointer that can be passed to C functions. All right. So okay. At least we established a table, and now as we add more and more things that are built in, we can extend that table, and maybe at some point people will find this table useful when they look for these kind of functions or whatnot. I don't know. It would be kind of cool to maybe automatically generate documentation from the source code. Maybe it would be better to actually put some comments in here and whatnot, and the signatures will be actually signatures of these natives. We do have plans for that, but for now, let's just maintain the table. Let's just maintain the table. Just maintain the table. Okay, so let's add the stuff. Let me see. 35351 document. Built-in native functions. So let me push that right into the repo, mate. Right into the repo. So compare and pull a request. Introduce built-in external native function. Okay, and close 351, right? Close 351. How about my space on the hard drive? So I have 3 gigs left, which is nice. Okay. Okay. Noise. I am like that in real life too, believe it or not. I'm a really weird person. So people who know me IRL, they will confirm. Okay, so let's do the branch, and yeah, okay, it's pretty cool. Pretty cool. Okay, let's fetch the latest stuff. Okay, so we have like I wanted to do like a 2 hours stream, So we have like a 15 minutes left, and maybe within like these 15 minutes, these 15 minutes we could have actually fixed that thing that we found in what? Sorry, for what? In a standard library. So it's lib. I forgot the folder where it's in. Okay, so here it is. Yeah, better way of allocating memory for standard printing functions. We have a better memory. We have a better way of allocating that memory. So that way looks like this. So if you take a look at the example, SDL BASM, so byte array, yeah. So you provide the size that you want in here, right? You provide the size and you provide what you want to fill it with, right? So essentially you can just replace this with the byte array. Your size, I think I remember it was 30, right? And it's going to be something like 0. There we go. So, and it's pretty quick, it's pretty easy, and let's try to recompile that and run tests and see if everything works correctly. So maybe it was too easy actually. Didn't expect it to be so easy. Yeah, there we go. But we even have like a whole separate issue for that. And since we have a whole separate issue, let's create a separate pull request as well. Why not? Okay. Better way of allocating memory for standard printing functions. Printing for yeah, STD printing functions. Functions. Better way of allocating memory for STD printing functions. Sounds kind of funny, not gonna lie, but I mean, haha, STD joke, by the way. He's a 15 years experience programmer in C and C++, and he still makes STD jokes. Yes, that's how immature I am. I'm so immature that I created a library called AIDS, which is supposed to be a replacement for STD. I program in C and C++ for quite some time already, but why am I still making these kind of jokes? Because I'm literally a child. Anyway, so you can find this thing in here, and I'm gonna put it into the description. Right, so here's the thing I wanted to mention in here. This idea of like a description file is actually pretty cool, I think. So I won't forget to provide all of these things in here. Yeah. Yesu. Kawaii fucking this. All right. Did I commit any? Did I push anything? I don't remember. So I think I didn't. Okay, let's push that and create the pull request. Let's push that and create the pull request. The pull request. That was too easy. It's not enough time to fill in 15 minutes, but maybe it is not even needed. Maybe that is not even needed. Who knows? Who knows? Maybe that is pretty much it. Just waiting for the continuous integration. Everything seems okay so far. Hopefully I didn't break MSVC. To be fair, this change is actually doesn't change anything in the C code. It only changes the BASM code, which is also my thing. Right, so it's purely like a BASM change. And GitHub does not highlight BASM code. Why? Well, because we are irrelevant. This project is irrelevant. I don't know, I think there is a way to make things like highlight on GitHub. You submit like a special file to special repo, they review that and they agree, they merge it and it automatically works or something. I remember, yeah, I remember somebody telling me that, but I forgot. I forgot how it works and I'm too lazy to research again. Too lazy. All right, looks good to me. Thank you for your contribution, Tsoding. That's pretty cool. All right, so how many pull requests we made today? I'm so productive. Holy shit, this is insane. So yeah, we made 3 pull requests. Wait, no. Extract verifier entity Okay, so, but I mean, this is the changes from the previous stream, so this doesn't count. But technically, we did like a 4 pull requests on today's stream, and it was extremely fun, and I really enjoyed it. I wish I could ask if you have any questions, but I still can't do that. Do you have any questions? Leave them in the comments below. Don't forget to hit like and subscribe, and also the bell notification and shit like that. Did you know that 5% of you are not subscribed to this channel? Well, I'm essentially becoming a YouTuber. Well, I mean, yeah, if you have any questions, like leave them in the comments, and also you can submit an issue or maybe even pull request. You can find the source code of this project in the description, and I continue my vacation. Okay, I'm on vacation. Right, and that's literally my vacation. So this is literally a vacation of a workaholic, right? That's what it is. It's so funny and pathetic at the same time. But I really enjoyed it. I really enjoyed this kind of style of streaming, and I'm not sure how watchable this stuff is. Maybe it's completely unwatchable because there's no like interaction with each other or something. But that was cool. That was cool nonetheless. Thanks everyone who's watching right now. Really appreciate it. Have a good one, and I see you maybe tomorrow. If I upload this video and it will do well, maybe you'll see me tomorrow. I kind of want to continue. I kind of want to continue doing this thing because I don't want to abandon those projects. So those projects are like my heart and soul, and it's just like, even though I'm not streaming, I just like I need to work on them. It's just what that's who I am. That's what I am. These projects define me. I just cannot leave them. They're like my children. They're like my children. I love them. So yeah, see you all tomorrow. Check out all the links in the descriptions, and check out the Discord server, I suppose. So not everyone has an access to it because we have some spammers, but you can find Discord link in there. And if you're a Twitch subscriber or Patreon subscriber, you would be able to have a voice in there. If you are neither of those things, you still can join, but it will be only in read-only mode. So you still will be able to see notifications, like announcements and stuff like that. Yeah, sorry about that. Anyway, thanks everyone for watching. Love you all.